I'm looking at some of the ideas here that I'll go into more detail, but this talks about software engineering for Monte Carlo simulation. Now, Monte Carlo simulation is the main engine that uses all those stochastic equations and get us the kind of output that we are looking for. The other thing is using different filters to get the parameters. We are looking at uh, how, if we were to build a software that would do this simulation, how would software engineering concepts help us to do that? So the first step here is to understand the process in Monte Carlo simulation. Then the process models that could do so, a waterfall model or rapid application development, or how we are going to build up this. Then you have the evolutionary design model, the importance of feedback. You can think of this as you keep on evolving as per the requirement changes. Then you have agile technologies that talks about flexibility in modeling. Then you have requirement and design, where you can link them. System engineering that talks about how the input and output interface and the processing would look like. So input would be like past data, output would be like future data, and things like that. And finally the testing part, where we believe that this could fail. So we would like to use all these concepts to find out how we are going to do this for Monte Carlo in software engineering framework. So let me go back and talk about these topics so that we can have a better understanding here. So in terms of a general view of process, we have to understand that what we are looking at here. So the process pattern and the process assessment would be first part. That is not so much crucial, but the crucial process is process model. So we have prescriptive models like waterfall model, and the incremental model like incremental model, and the rapid application development model. So these are the kind of process models that we could link. So as we can think of it, the waterfall model is an old technique. We will use the rapid application development model. Then even the evolutionary process model, we focus on prototyping, and the spiral model, where we will go back and look at the requirement, because we are not sure how we could link them, and whether the engine is taking too much time, or other trouble that we might face at. And then we have the agile view of process. So if you look at some of the topics or while you do the analysis in Excel, it is called like agile, lean, Six Sigma, which means that it's flexible. You can change the requirement in between. That is the meaning of agile. Lean is you are recycling the waste in a very smart way. So if you are coding something, you're not letting it go in a way, so you make it that ways. Then Six Sigma means that you remove the error, because if something fails, you get wrong path, you can still catch that. Then you have requirement engineering. It's about inception, as in negotiation, specification, related requirement. So then you have other software engineering core principles. Design engineering, which is abstraction, architecture, pattern, modularity, information hiding, functionality, refinement, refactoring, design classes. So the design engineering starts with abstraction, architecture, patterns, modularity, information hiding, function independence, refinement, refactoring, design cases. Then you have system engineering, which uses something called UML. It's quite famous, unified modeling. So that would talk about how the input, output, and the system would look like. So it's a way in which looking at the system based on input, output, and defining how that would change. So that would be a part of system engineering. And then finally is testing. So this is one very gross framework which you can use to build up these kind of models in software engineering.